Okay, so I thought we could use a little bit of a visual for Unit 2, these physical and chemical changes. So today we're going to do another online lab where I perform the lab for you and you analyze the data. So we're going to need some test tubes, a test tube holder, some water, and hydrochloric acid. But first things first, we're going to put our safety glasses on. Okay, here is our test tube rack, and we're going to start putting test tubes in it to test these chemicals. Now we need to label these things to make sure we don't get confused. We're going to put water at the top. We're going to put hydrochloric acid on the bottom. So the first test tube is going to get copper, the second one is going to get zinc, the third one is going to get magnesium, the next one is going to get zinc sulfate, the next one is going to get ammonium carbonate, and the last one will get calcium chloride. So here we have a little bit of copper in this test tube, and we're going to put a little copper in this test tube as well. Now on our lab sheet, we are going to make observations about what this copper looks like. I don't know if you can see it really well, but it looks solid. It looks orange. They're in the shapes of little balls. The zinc looks a little bit different. It's more silver. It has more jagged edges. And the magnesium looks solid, less silver, more gray, and more rounded edges. Now this is zinc sulfate, and it is a white solid powder. The ammonium carbonate is also white and solid. It's not exactly a powder, but it does have a strong smell. And the calcium chloride is a white solid that's in the shape of balls. Now what we're going to do is add water to each of these and see whether there's a physical or a chemical reaction. Did the copper change? Did the zinc change? Did the magnesium change? Let's give these a swirl and check up back on them to see if anything happened. The copper still looks like it's still solid and orange in there. The zinc still looks silver and jagged. The magnesium still looks gray, maybe a little black, and not very jagged. The zinc sulfate doesn't look to be dissolving. No reaction with water. So the ammonium carbonate had a little bit of a reaction with water. Looks like it bubbled a bit there. As well as the calcium chloride, it looks like there was a little bit of a reaction there as well. But this is less interesting. Let's try adding acid. So the reason we have 2 test tubes of each chemical is because we're testing one of them with water and the other one with acid. So now we're going to test these all with acid. Doesn't look like it's doing anything to me. This is definitely breaking down the zinc. If you can see bubbling, that indicates a chemical reaction. Again, this bubbled pretty ferociously, so we definitely have a chemical reaction there. It seems to be a weak reaction with the calcium chloride. So under observations, you're going to say what you can observe from these things. It seems like the copper with acid, it got a little shinier, but it's basically just got wet. The same with the water. There was a definite reaction with the zinc and the HCl. There was bubbles. It seems to be dissolving it. And there was a definite reaction with the magnesium. There seems to be bubbles, and it seems to be dissolving. With the zinc sulfate, though, it doesn't seem like the acid did anything. It's still just a solid on the bottom. For the ammonium carbonate and acid, there was a definite reaction with bubbles here. And there was a slight reaction with the calcium chloride with acid. Okay, but what does all this mean? Basically, what we're trying to find out is whether something changed its identity of the substance or whether it did not. Whenever we had something like the copper react with the water, it did not change the identity of the substance, and neither did its reaction with the acid. But our reaction with zinc with water did not change the substance, but our reaction with zinc and acid did. So then we would write zinc with acid is a chemical change. It is forever changed. It cannot go back to what it looked like originally. But I hear you. You guys are like, Mr. D, how do we analyze this data? You can't just give us a blank piece of paper and expect us to be able to fill it out. Well, you probably can. Okay, so the first thing we want to do is fill out all the chemicals that we use today. Now again, remember our observations before we did anything to these chemicals. Okay, now we have 2 rows to each of these, whether we added water or acid to them. So we might want to mark those just so we know. Okay, now we are going to go through and put our observations when we added the liquids. Now basically what I'm going to write when kind of nothing happened is that it just got wet. Okay, so you might see one of the ones we haven't done yet is zinc with acid, and zinc with acid bubbled and got cloudy. Now what I wrote down is that magnesium with the acid fizzled wildly. Next we have ammonium carbonate with the acid. And I also have bubbled wildly there. And for the last 2, calcium chloride with water and acid, I had that they slightly bubbled. It was hard to see, but it was easier for me to see in person. Okay, last thing is just to say whether it's a physical or chemical change based on the observations and what changed when we added the liquid. So anything that we're saying just got wet or didn't change very much is a physical change. Even if something dissolves, it can be a physical change, but if something bubbles, it would be a chemical change. Even if the reaction was very slight, like the calcium chloride, it still counts as a chemical reaction. Now, I'm sorry we couldn't do this in class. It's just the way things are right now. I hope this was at least a little bit enjoyable for you. And if you have any questions, let me know, and thanks for watching.